In this demonstration, I'm going to show how to add data integrity tests to CD pipelines. So data integrity tests can pose a significant challenge to organizations. And really by adding this as part of CD pipelines, we can ensure that application changes don't also cause issues to our production data. The use case of this was really thought up by Stephen Atwell at a previous company, where the most effective way for their product teams to catch issues was to take a copy of a database, run reports against it, and then compare the outputs of those reports from before the upgrade and after the upgrade. And that's really what we're replicating here with this demo. So a little bit about how this works. We're using ArgoCD with a GitHub repository in order to capture all of our code. We also have two clusters, a production cluster and a staging cluster. The application that I'm going to demo this with is Portworx Barbecue, which consists of a front-end web application and a back-end Mongo database. First, periodic replication is set up between these two clusters. We're going to take the Mongo PVC and copy it over to our staging cluster on a timer. The reason that we are doing this on a timer versus on demand is because we want an up-to-date copy of this PVC to be present on cluster 2 to reduce the amount of time it takes for that transfer. As we can imagine, our data sets may be especially large. Notice, though, that our applications are not actually running on the staging cluster until we get to the testing phase of a new code rollout. What we're going to do is actually create a staging branch and trigger a synchronization of the application that is running on the staging cluster. Now remember, it already has an up-to-date copy of all of the data. It also is presumably synced to the same version of Portworx Barbecue and MongoDB that is in the production cluster. We're going to scale up the application and test on the existing code base. Again, with the existing data set that mirrors production. This is then recorded in an object store, our test results. Next, we're going to upgrade based on what's in the staging branch. This is the actual sync process, and rerun those tests as a post job. That same job then triggers an evaluation against a little application called Barbecue Taster, which is going to ensure that the results are the same. Once that's successful, we're going to merge our staging branch back into production, which is then going to sync the production database. Let's see this demo in action. On the right-hand side of my screen, we can see this Portworx Barbecue application. I'm going to go ahead and log into it. And put in a new order. We can see that I have an order number. And I can also see this order as well as previous orders in my order history. This is all persistent data that we're going to want to test against to ensure that our database is consistent both before and after the upgrade. Let's take a look at the data movement between these two clusters. On my source cluster, Let's go ahead and take a look at the cluster pair object. This cluster pair object is what defines the relationship between our production cluster, which is labeled Demo1, and our staging cluster labeled Demo2. This has information such as tokens and API endpoints to ensure that these clusters can coordinate failover operations. The next thing is we have a migration schedule, as well as migrations that are triggering every 15 minutes to ensure that we have an up-to-date copy of the data. This migration schedule contains information about what namespaces we want to move, what resources within those namespaces we want to be copying over to the staging cluster, as well as some other information. We can see here that we are using a schedule policy, and that happens to be triggering that replication every 15 minutes. It's important to note that this replication is being done by way of an object store. I'm now going to start monitoring what's happening on my staging cluster, as well as what's happening on my production cluster. We can see the production cluster has both Mongo and our Portworx barbecue pods running. We can also see on the staging cluster that neither of these are running. Let's start by creating a new code branch. Okay. With the branch created, let's upgrade MongoDB to version 6.0.2. We're now ready to sync the application. Let's take a quick look at the manifest we're going to use. This is the PX Barbecue staging application. It describes the destination, the namespace, as well as a customize build for PX Barbecue stage. This captures some of the changes between production and staging, while still allowing us to make a single change to the MongoDB version and have it upgrade both places. Also notice that we are looking at this PX Barbecue stage branch. We are also looking for manifests underneath the barbecue taster folder or directory of our repository as well. I'll show you the code behind this a little later, but the manifests underneath barbecue taster are what run the testing hooks before the sync happens and after. Because remember, we're going to scale up the application on its current version, run some tests, then upgrade, and then test the application again. Let's go ahead and trigger that application sync. Okay. We can see that we're scaling up MongoDB. We're going to give that a moment to come online, and it's then going to start up the PX Barbecue web front end. Now that the web front end is spun up, we're going to run a test against the database. We're going to look for the number of registrations we have to the loyalty program, as well as the amount of orders. Now, this integrity test could be anything we want it to be. But the closer we can be to looking at real values that would catch issues, for instance, a difference in the amount of orders between before the upgrade and after the upgrade, we have a high chance of catching issues. Now that the test is completed, we're going to scale down the old version of Mongo and scale up with the new version 6.0.2. We're now going to run our second set of tests and put the results in that same object store. Now that the tests have been run, we actually scale down the application. After we've run the comparison, which is acting as a webhook that's actually running as that barbecue taster pod that you see, that is comparing the results in the object store, which is essentially running a diff, and replying with a code 200 if our results are the same before and after, or with a 404 if they're not. It's also putting its results inside of that same object store. We can take a look at that by pulling down that object. Looks like the contents of the two files are the same. The barbecue taster app can perform these evaluations between these results at any point, as it's a simple webhook. We can see with my curl command that I get the same set of results, 6 orders across 2 registrations. Let's go ahead and take a look at the difference between our production and staging Mongo versions. We can see that staging has now been upgraded to 6.02 and production is still on 6.0.1. We're also very sure that our upgrade is going to go fine. We tested with a copy of the data. Let's go ahead and merge our code with main. And let's go ahead and sync our production Portworx barbecue application. All right, it looks like the new version of Mongo is up and running in production now. And we can see that both our staging and production Mongo versions are now on 6.0.2. We've seen how this transfer happens using Portworx on the back end. Let's take a quick look at the pre and post hooks that Argo is using to perform the actual tests. We can see here both the pre-taste and post-taste jobs that are running the tests against our Portworx barbecue application both before and after the Argo sync takes place. This is accomplished by the annotations on line 8 of both files. We have also put an annotation in that we will delete this job object if our hook succeeds. The test itself, we can first see our scaling, is a custom application called the barbecue uploader, which is performing the test and uploading the results into an object store. The information is all contained within a secret. It's a similar execution on the post-taste job. First running the barbecue uploader, and then scaling down the application, and lastly connecting to the webhook, the pod barbecue taster, and looking at that result. I hope this demo was informative as a taste of what's possible when we combine tools like ArgoCD with Portworx. Portworx's ability to move data between clusters in a Kubernetes native manner provides a lot of benefits to GitOps and other tools. To be able to do testing, to be able to provide application failover, as well as a number of other benefits. To learn more, visit us at portworx.com.